Okay, so here we have a problem where we have an ellipse, we have a tangent, but we don't know where the point of contact is. And you can see it, like, it's actually kind of hard. You couldn't even really eyeball this very accurately. So how do we find it? Now this is a slightly unusual bit of geometry, but it's a really useful one to know, and it's actually not that hard. So first of all, what we need to do is we need to try and find the center of this ellipse. Now we're not given it, a little bit of a nuisance, sometimes you are, but we know it's in the middle, so we're just going to bisect it. So our usual method, bigger than half. There we go. And we, of course, need to extend that slightly further. There we are. Now, grab ourselves a set square. And we'll find the center line. Okay, so there is the center of my ellipse. Now, so that's step one. Bisect major. Major axis. Step two is going to be to draw the major circle. Alright, now that we have the center, that's fairly straightforward. So pop that in the center there. Now we go to the edge. And there's our major circle. Ta-da! Now, this is the key. Where the major circle contacts the tangent, we're going to get 2 points. Alright, and you extend your tangent if you need to, you'll get them eventually. These points, if we go perpendicular to the tangent, okay, it's like a normal. Oops. There we go. So there's our tangent there. And if we take a normal to that, okay, well, sorry, a line the same angle as a normal, we will find our focal points. That's focal point 2. And up here is focal point 1. So this is our key bit here, okay? Just make a little note of that. Okay. From intersection of the tangent and the circle, draw a perpendicular to find the focal points. Now, okay, so there is our 2 focal points. Now, how are we going to find the exact point of contact? Well, to find the exact point of contact, we're going to do a nice little clever construction here. Okay, so we'll extend this up, and this might seem a little bit weird at first, but actually if we keep an eye on it, we'll see how it's going to relate to what we already know. We're going to copy the distance from this guy up. Okay, there we go. Copy that up here. So I'll just pop that into a little bit of orange as well, and you can see that that is the same as that. All right, same distance. Now we can connect this guy. All right, and there's our point of contact. Now, why the hell does that work? Well, if we think back to our construction at Junior Cert, what we'd have done is, if we had the point of contact, we'd have gone from this focal point up through it, and we'd have gone from this focal point up through it, and we'd have bisected these guys. All right, and that gives us the tangent, and off we go. So let's see what we did. This triangle here, okay, and this triangle here are the same. All right, since they're the same triangle, okay, this angle and this angle are the same. So we've gone back and recreated that bisector. All right, so it just might seem a little bit unusual, but take a little moment and have a look at it. We've essentially recreated our Junior Cert method by working backwards.